I'm super excited to tell you about this project that I've been working on. It's on topic modeling and it's on validation of topic modeling. And I have worked on this particular project for quite a while now. And because every time we tried to write it up as a nice paper, somehow the storyline shifted again. Because there are actually a lot of implications that we in the beginning didn't foresee and that kind of came up whenever we tried working with it. And so today I tried to go a bit of a different route and not present a formal presentation, but I decided to do a short story on topic modeling. And I hope that you can see the slides now.
Perfectly.
And awesome, perfect. So this is going to be a short story on topic modeling, and all the pictures that are in my story I created with DALL-E, so they are not my pictures, but I think they do a nice job of underlying the story. And the formal title would have been more like validating topic models, does it matter how we do it? And so, okay, now it works. There once was a PhD student, we'll call them Robin, who wanted to study which issues were important in Austrian politics in the past 15 years. And so our PhD students decide to collect press releases from all the parties that are currently in the parliament, because press releases are a nice way of knowing what parties talk about. We have research on agenda setting that actually works with press releases a lot. And so this is a data source that is kind of used already. And so what they find is that there's actually a lot of press releases in Austria, and that in the years of 2005 to 2020, there is 218,000. And so that's a lot, and it's a lot to read on your own. And so Robin decides to research computational methods and finds some really interesting texts on a method called topic modeling, and also some really good introductions to topic modeling, and especially one specific method that's called LDA. And they find that LDA is the most used topic model, especially in computational communication science, but also computational social science in general. And also some very good explanations on how to implement that scientifically. So there are a lot of resources that can be used to do that. And so that's what they did. They first started fitting hyperparameters, so using two different pre-processing settings, and also collaborating with some computational scientists, and then started to maximize the hyperparameters on NPMI coherence. So what we found was many different coherence scores. They all looked relatively similar for the similar pre-processing settings. And then the PhD students decides to look at the best two models. So the two models that perform the best on NPMI, and they decide to further validate those two best performing models, because even though they have quite similar coherence measures, actually they have very different different number of topics. So the first one found 40 topics, and then the second one had 50 topics. And so research suggests that we need some humans in the loop for validation, and that is recommended, so that we do not solely rely on these automated model evaluations. And so they look for different possible validation strategies that could be implemented, and they find a very handy literature review on how to validate topic models and which methods are out there. And that also included some guidelines. And these guidelines are how important it is to validate and to use different validation methods. That it's also, there's no need to reinvent the wheel, so we can use topic modeling validation methods that have been proposed before. There's no need to make your own fancy method of how to validate that. That it's super important to standardize the reporting so that you can read what others write about, and so that you can actually replicate that in an easier way. Then we said that already humans should be in the loop, and ideally theory-based decision-making should also be implemented somewhere in case the research question builds upon theory that we know before, or data that we have some kind of external information for. Okay, So in the first step, Robin asks a research assistant to perform a word intrusion task. And that's a validation method that has been around quite a long time and has worked actually quite well. And so there are 9 top words for each topic and 1 intruder word for all the topics. So what the research assistant got was an Excel sheet. It always had 10 words, and then they had to mark the 1 word that did not fit with the others. And to the great surprise, these models perform actually quite bad. So even though the coherence scores were quite good, the word intrusion task did not work very well for these 2 models. So only 7 out of 40 topics or 7 out of 40 intruders could be found correctly in the first one, and only 9 out of 50 were found in the second one. Nevertheless, Robin decides to go on and in a second step reads some classified documents. So for each topic, they found which documents had been classified into these topics, and then they read the 5 documents in order to assess how many of the topics or how many of the clusters that were found are actually meaningful. So meaningful would mean that a person can label them, can give them a name, and useful topics. And useful in our sense means any topic that is somehow related to Austrian politics, because that's the data source that we used. So we wanted to find out how many topics of each of the models were workable or were usable for the project. And that actually, to great relief, worked a lot better. And the measure suggested that the models performed actually better than all the people initially feared. So in the first LDA model, there were 82 meaningful topics, and then in the second one, it was at least 62. So that's something. And there are actually some really interesting insights. The validation results suggested that the first LDA model was more useful. However, during the labeling, our PhD student got a bit unsure because it's the first time doing topic models. Also, some things did not add up. And so thus they also decided to compare the content of the 2 models so that we can kind of get the theoretical decision-based approach in there. And so after labeling all the meaningful topics, there was a very unwelcome surprise in that the models only shared 9 topics. So that's 28%, and then they disagreed on the other 72%. I highlighted the ones that they share. So these are some bigger policy topics such as education or energy and pensions. And so some of these, that makes sense for Austrian politics. A lot of these topics do work. However, there are some that are similar, but then depending on the labeling, they still got a different topic name. So they're not quite the same, such as, for example, discrimination and violence against women. So we can see that they are connected, but also not quite exactly the same. And then there are some rather vital political issues, for example, agriculture or health policies, that we only found in one of the 2 LDA models. And that was a bit concerning, seeing that the research question was, what did parties talk about? And then if we do not, if we have a model that does not include these really big issues, that's potentially a threat to our validation. And so extremely unsure with these results, Robin starts to read a bit more on topic modeling and finds that LDA is actually being criticized quite a bit, and that there have been technological advancements that led to the development of multiple new topic modeling methods. And so they find one that seems very promising. It's called Top2Vec, and it's based on neural networks or word embeddings, and it does a distributed representation of topics. And it works, if you know it, quite similar to the bird topic, actually. The main difference is that you can choose your own embedding or use any other pre-trained embedding, not just the different bird ones. And so Robin does the same steps again so that all the results become comparable. So first, NPMI coherence shows that the Top2Vec models perform really badly compared to LDA. And these are the green lines in the graph. And they don't perform as well as the LDA models in that sense. However, surprisingly, when we look at the human-in-the-loop validation steps, we find that Top2Vec actually produced very, very useful topics or very useful models. So the first model was where we found 74 out of 36 correctly identified intruders. That's over 70%. And then the second one, this was even over 80%. And then especially when we looked at the in-depth reading, we found that 69 and 90% were meaningful and useful topics. So that's actually a very good step and a model that, at least on a first glance, showed us some very useful topics. And so again, from these validation results alone, it was not clear whether the first one or the second one was a lot better, but they differentiated a lot on the topics. So the first one had 63 topics and the second one had 30. So there is definitely a difference. And so again, theory-wise, looking at what we know about Austrian politics, which issues are there, again, Robin wanted to compare based on the content. And so this time, the models share 52% of the topics, which is a lot more than 28%. And also, upon closer inspection, those differences are solely due to the differences in K. So all the topics that are present in the smaller second Top2Vec model are also present in the first one. So there is something, and Top2Vec leads to more stable topics, at least when you compare these two models. And we only compared two for every one of them. Now, when we take one step back and reflect and repeat what just happened, what happened was there were two different topic modeling methods. They were applied to the same text corpus. The hyperparameters were in both cases adapted to maximize NPMI, and then we chose the two best performing models for further validation. The word intrusion showed that there were substantial differences between the two methods. So the LDA with a very low word intrusion and the Top2Vec with a really high word intrusion percentage score. But then when we looked at the in-depth reading, we found that actually all four models worked quite okay. So 3 worked really well, and then the second LDA model worked okay-ish. And so we found that all 4 of these actually could tell us something about our research question. So there once was a PhD student who wanted to study which issues were important, and they used topic modeling to do it. And depending on which topic modeling method they chose and which validation method they chose in order to know which model in the end to use for the analysis, the results differed a lot. And that's problematic because of the 63 topics that were found by all 4 of the models, if we combine them, only 4 of these were in all of the models. That's event notification, so that's everything from there's a press release, someone got a new job, or someone passed away, to unemployment, education policy, and pension policy. Now, these 4 things are theoretically make a lot of sense. They are supposed to be in all of the models. They are some really big issues in Austrian politics, and so that makes sense. However, there were 30 topics which only appeared in 1 of the 4 models. And this can be larger topics such as corruption or sustainability, or it can be smaller topics such as illnesses, in that case, COVID-19, or genetic engineering. And so we can see that the models pick up on different patterns and show us different results. And this leads us to a problem, because which of the following results section now is the correct one, or the correct one, the real one? And so depending on which model we would have chosen, and depending on which validation method we would have chosen to decide on an actual model, we would have gotten rather different results. And that's problematic, because what does that mean for the application of topic models in substantive computational communication research? How can we use topic modeling to answer substantive research question without having to try out 10 different topic modeling methods, without having to apply a plethora of validation steps that in the end would actually take us a lot more time than if we had taken a random sample and manually coded some of the texts ourselves. And so this is one of the questions that I'd love to discuss with you today. So how can we use topic modeling Should we use it for measuring, or should we more focus on topic modeling as a form of discovery or explorative research? Should we focus our attention more back towards manual content analysis and how we can use kind of topic modeling to augment that and help us with manual steps? Or can we actually think about validation methods or validation steps that could help us with this problem of unstable topics over different methods and different models? Yes. So I also have some ideas on that, but before I'll talk about them, I'd love to hear any questions you might have and any of your input and your thoughts on this project. And I would invite you to be critical, to give feedback, because yeah, this is what we found, but I'd love to hear what you think about.
Thanks, Jana. And what beautiful way to present this. I'm